Hello my dear friends, welcome to our program for science third prep stage. Today we have another session about revision of all information in your student book. You have many questions to study, you have many things to do to get high marks in your exam. Let's start our program today and concentrate with me very well. Let's start. First question today we have give reason for. It's very important to know this one of these questions. Let's go to see the first one here. We have sodium replace hydrogen from the acids but copper cannot. It's two parts of this question. So the sodium replace hydrogen. It's very easy and very clear for us. We have the sodium replace hydrogen because sodium is an active metal. So it is more active than hydrogen. Okay. In chemical activity series, it's found before hydrogen. But we have the copper here. Copper, it means what? It means they replace hydrogen from acids, but copper cannot, because the copper here, it's more active than what? Active than copper, and more active than hydrogen in chemical activity series. It's what? It's very important to know this one and write this expression in chemical activity series. Let's go to see another one. We have here the steel fibers is used in cleaning pots, okay, burning the cylinder full of oxygen more than air. Why? Because here we have the fibers here. It's cleaning pots, burn in the cylinder full of oxygen more than air. Why? Because the concentration here of oxygen in the cylinder is more concentrated than that in air. So here, this is the oxygen, it's found in the cylinder. So it is 100%. Because it's full, this cylinder or the cylinder full of oxygen. So it is 100% that found in the cylinder. But in air we have 21%. It's very small amount or very small volume that increase the rate of chemical reaction by increasing the concentration. So because the oxygen, okay, in the cylinder, it's more concentrated than that in air. To increase what? To increase the rate of reaction or rate of chemical reaction. Let's go to see another one of these questions here. A blue color of copper sulfate disappear by heating. Why? Because here we have what? We have due to the formation of copper oxide by thermal decomposition. Why? The copper sulfate, it's a compound. And we use the heat energy to produce another two compounds from this one by detection or by heat energy. So the heat energy decompose this compound. It's complicated into two simple compounds. We have copper oxide is black color or black precipitate, and we have a gas of sulfur trioxide. So the gas here, it means what? It means sulfur trioxide, SO3. And don't forget to write the equation. It's very important. It has a mark. So copper sulfate, CuSO4, blue color. It's by heat energy changing into CuO by black or black precipitate plus SO3. It's sulfur trioxide. Okay, let's go to see another one of these questions. The blue color of copper sulfate also disappear by adding a piece of zinc to the solution. So here the blue color of the copper sulfate disappear by adding piece of zinc. Yes. Why? Because zinc, it makes what? It makes reaction with copper sulfate, because zinc is more active than what? Than copper in chemical activity series. It comes out after the copper, so it is more active than this. Zinc, it's before copper. Zinc is before hydrogen in the chemical activity series, and the copper, it's after hydrogen in the chemical activity series. So the simple substitution takes place between the zinc and copper. Why? Because zinc more active than copper. Another question here, we have some kind of problems. Problems is very easy to know this. Why? Because problems, it takes large number of marks. Let's go to see. You have three similar cells. EMF of each one of them, it's 1.5 volt. So explain by using diagram. If I have explained by using diagram, it means show by drawing. So how can you connect them to obtain? I need to get amount of voltage from each one of the circuits that we have in this question. I need 4.5 volts, and I need in another one we have 1.5 volts, and here we have 3 volts. Again, read the question slowly and understand each part of it. You have 3 similar cells, so we must connect the 3 similar cells in a way. We have 2 ways, series or parallel connection. So after that, each one of them, it has 1.5 volts. Explain by using diagram. So show by drawing. I need drawing of each part of them. So how can you connect them to obtain 4.5 volts, 1.5 volts, and 3 volts? Which one? Okay, that we start with it. The first one here, we have 4.5 volts. Why? Because it is the easiest one. So the cells are connected in series connection. Why? Because each one of this one or these parts here, 4.5 volts, it's the series connection. So the total of this EMF of all cells, it's equal 4.5 volt. So here the voltmeter read here 4.5 volts. So after that, the second part of this question, to obtain 1.5 volt, it is more easier. Why? Because I connect the series connection here. No, I connect the parallel connection. Parallel, it means branched one. Each one of these parts here, we have the negative, negative, negative. And here we have positive, positive, positive here. So all positive parts or positive pole that connected to one end, and here we have all the negative poles are connected in one end that connected finally to the voltmeter to make what? To make 1.5 volts here. Let's go to see the other part or the third part here. Here we have 3 volts. To obtain 3 volts, it means what? It means 2 of them, it's parallel connection, and the other one is series with the parallel battery. So the battery here, it's 2 parts here, that parallel connection, and we have the third one here, it's series to the parallel battery. So here, which battery? The 2 cells here that connected to the parallel connection, it's called what? It's called battery. Why? Because it contains 2 cells. After that, another one of these problems, calculate the resistance of the conductor if the potential difference of it is 2 volts. So, and the electric current intensity is 10 amperes. We have 2 volts and we have 10 amperes. And I need to calculate the resistance. It's very easy. We have one rule here. The answer, it's R equal V divide I. It means Ohm's law. So the R equal 2 divide 10. So here we have 0.2 ohm. This is the measuring unit of resistance. It's very easy. But don't forget these advices. We have many advices here. Number 1, write the rule. And number 2, write the calculations that we made on the calculator, and write the unit of the last amount or last result that found here, because each part it has a mark. So the first one, we have the first mark about the rule. If I have no rule, we have no marks in this part. So I take 2/3. And the second one, if I have no calculation, I erase one of these marks. And the last one, if I have no units, is 0.2. 0.2 what? Kilogram or gram or what? So here, this is the unit. It's very important to know this. So in last time, R equal V divide I, R equal 2 divide 10. So the result or final result is 0.2 ohm. Another one of these problems here, calculate the electric current intensity that pass in the conductor. The quantity of electric charges is 10 coulomb. And we have passed 100 seconds. It's very easy to know this. Why? Because I have a rule also. So the answer here, we have I equal Q divide T. Q, it means what? It means the coulombs here, quantity of charges. So the T, it means time. So I equal 10 divide 100. It's equal 0.1 ampere. Don't forget the measuring unit of each one of these concepts. Let's go to see another one of these problems here. If the potential difference between 2 terminals or 2 ends of the conductor is 10 volt, and the electric current intensity is 2 ampere passing through it. If the potential difference here between the two terminals of the conductor is 10 volt and the electric current intensity is 2 ampere pass through it, what will happen? Here calculate the intensity of the electric current passing through the conductor if its voltage has 2 volt. What's happened here? The answer here, if I have R, it's V divide I in the first part, and 10 divide 2 equal 5 ohm. And here we have the I, it's equal V divide R, so the I electric current intensity, it's equal 2 divide 5 ampere. So here divide 5, 2 divide 5 ampere, it means what? It means I can make it on the calculator and or I leave it like this. So here we have V divide I, it means what? It means the R, or resistance. Resistance equal potential difference divide electric current intensity, and R, or the resistance, equal what? Equal 10 divide 2, so it is 5 ohms. And after that we have the electric current intensity, it is V divide R, it's 2 divide 5 amperes. 2 divide 5, it means what? It means about 0.4 ampere. We have another question here. We have another type of question that called mention the function of the following. Mention the function, it means what? It means I need to make uses of each one of them. What are the uses that found in each one of these parts? Let's go to see the first one, refrigerator. It's a very strange one. No. It's a very easy one. So the refrigerator here, it's related to the chemical reactions because it makes what? It makes decreasing the temperature to decrease and stop the chemical reaction of bacteria or fungi, or it stop the reproduction of the bacteria and fungi on the food to preserve it for longer time without spoiling. Again, the refrigerator, it makes decreasing of the temperature of our food. Why? To stop the chemical reaction or to stop the reproduction of bacteria and fungi on our food, to keep it or to preserve it for long period of time without spoiling or without what? Without making it more poisonous. Let's go to see another one. What is the function of catalyst? Catalyst here, it means it's a substance that speed the chemical reaction without any change of itself. It has no change in the mass, it has no change in volume, it has no change in the color, it has no change of all things about itself. So the catalyst, like manganese dioxide, it means what? It's speed the chemical reaction without any change of itself. So here we have the catalyst here that makes what? That make this shape. Let's go to see another one. Study the following figure, then answer the question. It's very, very important to know this one. Let's go to see. Here we have the concentration and reactants here, and we have the time per minute, and we have 1, 2, 3. So we have a graph. This graph represents a thing. So this is concentration. It is a relation between the time and concentration of the reactant. It means what? Speed of chemical reaction. Very good. So number 1 and number 2, number 3. If I have this equation, 2x give us 2y plus z. So which one that related to 1, 2, or 3? In the opposite graph represents the change of the concentration of reactant and the product during time. Okay, what will happen here? I need, in the following equation, we have 2x give us 2y plus z. Here we have, write the name of each number indicates. 1 indicates which part, and 2 indicates which part of the equation, and 3 which part. So, number 2, illustrate the change of reactants, the products of this reaction during the time in a table. So here we have 2 parts of this question. Again, this question, it means in the following equation 2x to y plus z, and we have the graph that represents 1, 2, 3. Which one 1, which one is 2, which one is 3, and we have the given here, or the order here of this question. We have write the name of each number indicates, and number 2, illustrate the change of reaction in the product, okay, reactant and the product of this reaction during time in a table. Let's go to see the answer here. So the number 1 represents 2x. Why? Because here number 1, It makes what? It makes, this is what? This is the product, number 1. And number 2, we have represent Z. It's very easy to know this. And number 3, it's 2y. So here we have, this is what? This is the types of the question. Let's go to see another part here. We have the concentration of 2x. 2x, it means a product. In the beginning of the reaction, it's 100%. It's very easy to know this. Why? Because 100%, it means it is completely without any change before or in the beginning of the reaction. Before the reaction or in the beginning of reaction. So the second one, we have concentration of 2y. It's 0%. Why? Because in the beginning of the reaction, we have no product to make. Another one, we have concentration of Z. Z, it means the second product here. So it's what? 0% also. Why? Because we have nothing about it. It's not formed else. After that, during the chemical reaction, during here, it means decreasing gradually. And the first one decreasing. Why? Because we have a relation between what? Between the product and the reactant. If I start the chemical reaction, the concentration of the reactant decrease and the concentration of the product increase. So concentration of yx or 2y, it's increasing gradually, and z increasing gradually until we have 1 second between them. They are equal each other or balanced to each other. It's 50%, all of them 50%, but in very short time it's equal or not equal 1 second even. So here at the end of this reaction we have 0%. Why? Because the reaction here or the reactants, it's finished. It will be finished. So we have nothing about it. And we have the concentration of 2y. It's 100%. And the concentration of Z is 100% also. Why? Because the chemical reaction, it's finished. So we have the many of the product that complete the reaction or produced from this reaction completely. So the concentration of each one, 100% of each one of them, 2y and Z. Another give reason for. We have here voltmeter is connected in parallel, but ammeter is connected in series connection. Why? Because here the voltmeter is connected in the parallel connection to measure potential difference between 2 points in the conductor. But we have the second part here, the ammeter is connected in series to measure the electric current intensity. So ammeter, I use it to make measuring of electric current intensity of whole circuit. But the voltmeter, I need to know, or I need to measure the voltage or the potential difference between 2 points, any 2 points of the circuit. Even we have the 2 points is what is before the lamp and after the lamp, or before the battery and after the battery. So after that, we have iron filling. Okay, react with acid faster than the piece of iron. So because iron filling is what is more than the piece of iron in its surface area. It's very easy to know this. Why? Because surface area increase, so the chemical reaction increase, or the speed of chemical reaction increase. Let's go to see another one. We have another one of these questions. We have the divided nickel is used in hydrogenation of oil industry. We have two things here. Because divided nickel is used as a catalyst, okay, to help the speed of chemical reaction without enter the change. But if I have the nickel or divided nickel that happened or that take place in the reaction more than a piece of nickel, so it is by increasing the surface area like the question before. Again, divided nickel is used in hydrogenation of oil and industry because divided nickel is used in catalyst to change the oil to butter. So the oil changed into butter by using nickel as a catalyst. It doesn't enter the chemical reaction completely. It makes the speed of chemical reaction without a change itself, without change in structure or color or mass or volume or anything of this. So it is very easy to know this one and very easy question. In this type of question here, we have what is the word equation of the thermal decomposition of sodium hydrogen carbon here. Hydrogen carbonate, it means what? It means bicarbonate. So the carbon monoxide, water, carbon dioxide, sodium hydrogen carbonate. It's what is the first one. Sodium hydrogen carbonate here, it means what? It means the first one here. And we have sodium carbonate that move out, okay? And what? And we have carbon dioxide and we have water. Why? Because here we have what? We have the sodium hydrogen carbonate. It's sodium carbonate that produced here, and we have sodium and carbon dioxide gas that appears from this reaction, and we have water also. Why? Because sodium hydrogen carbonate, it means here carbon dioxide comes out from carbonate, water comes out from the hydrogen here. So it is one of the equations that found in what? In thermal decomposition here by heat energy. Another one, we have in these statements about acids and bases, true or false. Alkali is insoluble base. Alkali is an insoluble. It's what? It's false. Why? Because most of one, okay, or most of bases here, or alkalis, especially alkalis, it's very, very strong reaction, but it dissolves in water very easy. Metal hydroxide react with acid, right? It's true. Why? Because they have what? We have the metal hydroxides like sodium hydroxide, potassium hydroxide. So we have the copper hydroxide. Any one of the hydroxide react with acids like HCl, H2SO4, HNO3 to make what? To make salt and water. It is a rule. Alkali contains positive hydrogen ion. Mister, it's true. It's false here. Why? It's not true here. Why? Because alkalis, it means metal that produce positive ion of metal, and we have positive ion, and we have here in these alkalis we have hydroxide ion. So here the hydrogen, it is not found here. Acids contain hydrogen ion. It's true. Why? Because the acid, it's a material that's what? That dissolves in water, forming what? Forming hydrogen proton or hydrogen ion that it change litmus paper to what? To change litmus paper to red color, and it has sour taste. And the hydrogen, it's responsible for many things or the old properties of acid. Hydrochloric acid is a weak acid. It's not true. It's false because it has corrosive action. It's what? It's very strong one. Ammonia solution, it is alkali. Ammonia solution, it means what? It means NH4OH. It's what? It's an alkali, right? It's true here. So here we have many things like the acids and bases to revise it. Another one of these questions here, we have in which salt produced by each neutralization reaction. This exercise, which salt is produced by neutralization reaction. All of them are neutralization, but I need here to revise the type of salt here that found in this neutralization. Sulfuric acid, potassium hydroxide. Sulfuric acid and potassium hydroxide, which one of them that make this reaction or produce this reaction? Potassium, here we have potassium, and here we have sulfuric. So this one, it's with the first one here. So it is easy to know this. Potassium sulfate comes out from potassium and sulfuric acid. HClNOH is very easy, mister. It's NaCl here that's produced by this one. So it is very easy to know this. And we have phosphoric acid, sodium hydroxide. They are two of this one, acid and hydroxide. So sodium phosphate, it's very easy to know this. Sodium phosphate here, and we have water. After that we have HClNH4OH. It means what? It means this one, okay? It's NH4Cl, it's right. And we have hydrochloric acid, it's copper carbonate. Hydrochloric acid and copper carbonate, it's which one of them? We have two. We have copper chloride here, that found here. And the last one, if I don't know the answer here, so it is what? It is very easy one. So here we have, this is the answer here. Again, sulfuric acid plus potassium hydroxide give us potassium sulfate and water. All of them give us water. And sulfuric acid, okay, with the potassium hydroxide, so here this is the potassium sulfate. HCl plus NaOH, it means NaCl. It's sodium chloride. So here we have two parts of each one of them. Na with Cl, H with OH forming water. After that we have phosphoric acid and sodium hydroxide. phosphoric acid and sodium hydroxide, it's sodium phosphate. So here the sodium phosphate here, it means what? It means it's hydroxide or sodium phosphate comes out from the acid and hydroxide forming water with the salt. And after that HCl NH4OH, it means what? Ammonium hydroxide and HCl. So it is solution of ammonia, NH4OH. So we have NH4Cl, it's formed, and HOH, it means water. After that we have hydrochloric acid, it's copper carbonate, it's formed copper chloride, it's very easy to know this. H2SO4 plus ZNO, it means ZnSO4. And this is what this is about, salts, and each one of these reaction that form salt of each one of them and water. After that, here we have another question about what? About the missing parts of the neutralization reaction. Here we have this NaCl, sodium peroxide, and we have sodium hydroxide and NaHCl. Which one of them is right? So here the hydrochloric acid I choose from this one. So NaOH, it means what? It means sodium hydroxide. It's very easy to know this. So the sodium hydroxide here, it makes a hydrochloric acid to make what? To make sodium chloride plus water. And after that we have what? We have NaCl and sodium peroxide. Which one here? I need to put one of these symbols here. Okay, so NaCl is right. Why? Because we have no NaHCl. So here we have the correction here is right. Why? Because here we have the sodium hydroxide, it's NaOH. And we have another one next. We have zinc oxide and hydrochloric acid. Which one is right here? This is zinc hydroxide or zinc chloride. If I have zinc hydroxide, it is wrong. Why? Because I need to form a salt. And here, if I put HCl, it's wrong. Why? Because here, if I have the correction, it is wrong. Why? Because here, HCl, it has no balance here. So if I substitute this one by the HCl here, so it is what? It is right. Like this. Why? Because I need the balance here of what? Of ZNO and 2 HCl to form ZnCl2 and H2O. It's very important to know these types of questions to make what? To make the revise many times. Dear friends, I hope to enjoy your time with us. You have a very large number of questions to study and revise many times. Till we meet again in the other one of these sessions of revision. Till we meet again, thank you and goodbye everybody.